Hi, welcome to Intro to 3D Modeling with Autodesk Fusion 360. Today we're going to be working on designing a skateboard wheel as part of a series where we're going to finish up building an entire skateboard. So today I'm going to get started by showing you the part that we're trying to create. So this is a skateboard wheel with its internal parts, which is a bearing, speed washer, spacer. I'm going to go through my design tree here to show you how I kind of built everything out. So I started out with a sketch for our spacer. I revolved that sketch around an axis. I then imported in a ball bearing from McMaster-Carr, which I will show you how to do. I positioned the ball bearing, and then I copied and moved a second spacer so that would sit on the opposite side of the spacer as well. Next couple steps were adding a plane and then drawing another sketch to extrude to create a speed washer that I then copied and pasted to sit on both sides of my bearings. And then I drew the profile for my skateboard wheel, and I also revolved that around an axis to then give me this part right here. So we'll be referencing this document, which I'm calling the anatomy of a skateboard wheel. So to get started, we're going to start with the spacer. I'm going to jump over here to a new sketch. If you look here on the top right-hand corner, you'll see our navigation bar. The navigation will let you view the front, top, left, right, back, and bottom of our 3D space here. And I want to get started by looking top down to do my drawings. And I'm going to start by clicking on this plane here. After I click Create Sketch, I will select the plane I want to work on. And let's get started. The first tool I want to use in our sketch is the line tool. And I'm going to create a perpendicular line, or two lines that are perpendicular to each other, and I'm going to make them both construction lines. Okay, so this is going to allow me to set up some guides for me to design in. Let's see, construction lines, and this will kind of anchor your drawings to the origin of this point. So when you modify your dimensions at any time later on, everything else will update according to the new changes that you make. So by taking care of this stuff ahead of time, you're going to save yourself a lot of work in the future. Now that I have these two lines perpendicular to each other, I'm going to select my bottom line and then the origin here, and I'm going to go to my constraints and select midpoint, so that my geometries are snapped to the origin. So now if I was to click and drag here, everything's moving about the center axis symmetrically, and I can't move it up or down. It'll just go left and right infinitely until I set a second parameter for width. But I don't really feel the need to do that right now. I'm going to be working with a rectangle and then using the dimension tool to snap everything to the drawing that I've created. So next step will be to select your rectangle, and let's just draw a shape of any size about this this axis going straight up. Okay, and you see these dotted lines. This means that when I drew the shape, that I still had the construction line selected. So we can go ahead and turn that off. And now once you see the geometry that you make, turn this light blue. That means that it's an active shape, and you'll be able to do further operations on this rectangle. So let's get started by setting our width, which is 10.135 millimeters, and then our height, which is 2 millimeters. Okay. Once we set these two dimensions, you can now drag the shape wherever you want to around in your sketch, and it isn't going to affect the height or the width of the shape that I created. So the final step before we do anything else will be to set the distance from our horizontal axis, and this is 8 millimeters. And then we're also going to set one more dimension from our right-hand side to our center line here, and we're going to do 10.135 divided by 2 so that it sets our shape halfway, or it makes our shape symmetrical about this vertical axis here. And once we complete that, we can hit Finish Sketch, and we've completed the sketch that we're trying to make. At this point, I advise you to save your document, and we're going to call this skateboard wheel tutorial. And I will save it. Okay. Now that we've named and saved our document and gotten this first sketch created, we're going to use our solid tool called Revolve. Let's see if I want to highlight Revolve. And anytime you highlight or hover over any one of these tools, a little description will appear. And so you can use this to figure out, the operation that you want to create. So we want to use Revolve to select our profile here. So here's the menu over here on the right-hand side, and this will let you pick and choose the different parts that you need to complete this operation. So the profile I want to use is this square. The axis I want to use is the one that we created around our horizontal line in our sketch. And once I select that, it completes the operation, and you can see we've created the cylinder with a hole in the middle. And so this will be our spacer for our skateboard wheel. Once we're complete, we can hit OK, and we will save as we go. So we, just in case our computers freeze on themselves, it's just a good thing to work on, or not to work on, to incorporate into your workflow so that you don't lose any information as you're working. Okay, the next step I'm going to show you guys is how to insert objects from McMaster-Carr. So over here in our tool menu, all the way on the right-hand side, we have something called Insert. And here you can insert decals, other drawings, different types of files. But what I want to do is insert from McMaster-Carr component. McMaster-Carr component is a huge database that has all different kinds of little components that you can then incorporate into your 3D models to make them realistic. And using the search bar up here, I'm going to search for a ball bearing. Okay, so I will click ball bearing. And since I've been working on this, I know the diameters or the dimensions that I want to use. And I know the shaft diameter is 8 millimeters. Okay, our width will be 7 millimeters. Let's see, and then our outer dimension is 22 millimeters. Okay, so I've selected this, and it will help me to narrow down the type of ball bearing that I need. And as you scroll down here, you'll see that there's different types of ball bearing. And I'll just use an open ball bearing, so just for the sake of this 3D model, that's what's going to work. And you'll select it, and then we'll give you an option how to download it. And for Fusion 360, it's probably going to want you to import a 3D SAT file, and you'll select that on your drop-down menu, and then you'll hit download. And downloading it will bring that into your geometry here, and we'll be able to adjust this accordingly. So I want to turn this 90 degrees downward, and then I'm going to move this object to the right in the sketch. Okay, let's orient ourselves using our navigation toolbar, and we want this to be, relatively close here. So let's zoom in, and maybe 8.5 millimeters is an appropriate distance. Nope, 8.75. That way we have a little bit of a tolerance here and that's a very small amount. So, if this was real life, this would be basically up against the spacer. So I'm going to hit OK, and now that component has been imported into my sketch. My next step is going to be to copy this ball bearing, so I'm going to select it. Using my keyboard, I'm going to use Command-C, or if you're on a Windows computer, I think the control is Alt-C to select it, and then Command-V for paste, and this is going to paste it in, and once this option comes up that says some components have been moved, you should select Capture Position, and so that's going to select the position that it's already in, and then you'll be able to move it from here to the opposite side of your spacer. So let's get this nice and close again, and then let's say 17.5 and see where that lands us. Oh, where'd you go? Negative 17.5. Okay, and that looks relatively close to what we did there. So I'll hit OK, and now we have two ball bearings on both sides of our spacer, and let's go ahead and save our document since we've gotten to this checkpoint. Okay, if we reference my original model, once I imported my ball bearings, I then created a plane, and I drew on that plane a profile, which we can see here, highlighted in blue. So we're going to do the same thing, and then we're going to extrude our speed washer. Okay, so I'm going to go back to my sketch, and it doesn't matter now. We can look at this front on, and we can start on the right or the left. I'm going to choose the right-hand side, and I'm just going to click on this face here and make it turn blue. Once it turns blue, I'm going to use my construction drop-down menu, and I'm going to do offset plane, and this is going to allow me to create a plane in space that I can then select and draw from. Now that I've selected this plane, we can do 0.5 millimeters or 0.25 millimeters, so we have a really small tolerance on this. So you can see that there's this little gap like we've been creating on everything else. And then I'll hit OK. And so once that operation is complete, it'll give you this orange plane that you can then select and hit Create a Sketch. And so now we have a new plane to draw on, and we're going to start by drawing two circles. So the first circle will be the inside diameter, which we'll just draw to here, and then we're going to use our dimension tool to then set our final diameter, which we'll have to go back and double check what those measurements were, but that's not a problem. So I have two circles about my origin here. I just click the origin of where my X and Y axis is here converging, and just click it and then drag your shape and then click to complete the circle. Okay, let's go back and look at the sketch that I had previously made. And here it is. So let's edit sketch and see what kind of dimensions we have. All right, we have 8 millimeters on the inside and 18 millimeters to the outside. So we're going to use our sketch dimension tool, select the circle that we want to set our dimensions on. So the inside diameter was 8 millimeters. We type it in and then hit enter to select it, and then our outside dimension was 18 millimeters. So we'll type in 18, and now we've completed our sketch. Okay, so at this point you can hit finish sketch, and you have this new shape that you can then highlight the profiles on. And so if you change directions, you can see that this sketch is sitting on just offset slightly from this surface from our ball bearing. So the next operation that we're going to use is extrude. So that's the second tool in our toolbar up at the top of the screen. So we'll hit extrude, and then we can select the profile that we want to use. We don't want to use both of them because this will give us a flat spacer, but we need room for our axle to fit through. So we can cancel that selection and select the outside so that's the shape of a donut. So when you extrude an object, you're making a shape in 3D space that you're turning a 2D drawing into a 3D object. And if you pull it out from you, Fusion has this nice feature. It turns it into your 3D object, but if you go the opposite direction and you have a geometry there, you can then use it as a cutting tool. For right now, I think we're going to, I know we're going to just extrude it, and I'm going to set it at 1 millimeter for now, and then I'm going to reference my drawing here to see the thickness of the shape that I created. So to do that, you can right-click on the command or the operation that you created in this histogram down here, and then you can hit Edit Feature. Okay, and it looks like I did do 1 millimeter. So we've gotten to this point, or this checkpoint on our skateboard wheel tutorial, and we should hit Save so we don't lose any information in case the software decides to crash or the computer decides to crash. Like I said, it's just a good habit to create for yourself as you're 3D modeling. Okay, so now we have 2 bearings, a spacer, and 1 speed washer, and we want to copy our speed washer and put it on the opposite side. So we will select our new body, which is this one here, and we are going to modify. So let's see, you can move, copy. We're going to just do the same command. So select the body, Command C or Alt C if you're on Windows, and then Command V, and it's going to duplicate it, and you'll see that it's duplicated because it'll give you this option to move it once it first gets pasted. And we're going to move this to the outside of our bearing on the left-hand side, and then we can hit OK because this looks about right. And for the sake of things and for this tutorial, things can be relatively close since we're just learning some of the simple operations that we have here. Okay, so now we have 2 speed washers, 2 bearings, and a spacer. We can hit Save, and we can start working on the sketch for our wheel profile. I've drawn a basic guideline for us to follow so that we can create the profile of our wheel and adjust our tolerances so that we can make sure everything fits around our bearings and spacer. Okay, so I'm looking at my 3D model from top view down. I'm going to create a new sketch, select the plane that I want to work on, which is the XZ plane, and I'm going to start by creating a vertical and horizontal guideline or anchor point so that we have a place to work from. So let's get started with our horizontal line. It doesn't matter the size, but you want to kind of center it around our origin. So we'll select our line, change that to a construction line in our sketch palette. We're going to click on the line and then also hit Shift and select the origin so that we can midpoint this. And the midpoint tool is this triangle here in our constraint options. Okay, so now we have our line connected to our origin, and we're going to draw a vertical line from our origin straight up. And this line will be perpendicular to the line we just drew. So I'm going to draw that in, change this line to a construction line, and pull it up nice and high because I know that the sketch we're going to be drawing is going to be 35 millimeters tall. So now that we have our construction lines in place, let's get started by drawing our first 2 lines. So let's reference our guide here. So the first line we're going to draw is 10.25 millimeters from our axis. It's going to be 5.75 millimeters long. And so what I'm going to do is I'm going to draw this half here. So from this midpoint to the right, we're going to draw a step up, and then we're going to draw a 7 millimeter line to the right again. Then select the 3 objects that we just drew, and we're going to mirror them across our vertical axis. So let's get started. We're going to use the line tool, draw a point on our vertical line, doesn't matter where exactly, and let's get started. So we know this guy was 5.75 millimeters, and then we're going to draw a line straight up, Doesn't matter the height because we're going to add our dimensions once I complete this. So I drew a straight up step, and then this is 7 millimeters to the right. So now we have these two lines, 3 lines actually, that are to the right of our vertical axis. Okay, so now we're going to create a mirror. Okay, so hit create, go to mirror in our drop down menu, select the lines that we just drew, and we're going to mirror those objects around our vertical line. And that's going to take what we drew and then copy it over onto the left-hand side. And then select OK when you're finished. We're going to also now add the vertical dimension from the line to our horizontal construction line. And the first number was 10.25 millimeters, but I'm going to come back and just double check. So 10.25 millimeters to our 5.75 millimeter line, and then 11.25 millimeters to our 7 millimeter line. So let's use our dimension tool, select our 7 millimeter line, and then this will be 11.25. Okay. And let's keep drawing our sketch here. So now we can continue drawing the right-hand side of our skateboard wheel. So we'll click on the outside of our 7 millimeter line. We're going to come up towards 1 o'clock, and we're going to leave our measurement undefined for now, and then just draw a line straight up and to the right, and then we're going to draw a 7 millimeter line straight up and hit enter. Okay, so we've come up, done the stair step, come up towards 1 o'clock, and then gone 7 millimeters up. Okay, and the final line that we're going to draw before adding any more dimensions is from the top of the 7 millimeter line to our vertical axis. Okay, now that that's complete, we can hit escape to get out of our command here, or you can hit select to go back to your select tool. Let's use the sketch dimension to then set a couple additional tolerances. We know that this is 20 millimeters. 20, enter. Okay, and then we know that the distance from this 20 millimeter line to our axis, our horizontal axis, is going to be 35 millimeters. And I chose 35 millimeters because once we use this revolve tool, 35 plus 35 will give us a 70 millimeter diameter, and for the longboard that I'm designing, this will allow you to roll over big rocks, not be affected by any pebbles or anything, and just be able to kind of cruise and have a relatively fast board. Okay, so we've completed the right-hand side of our profile, and we're going to double check our guide here and then see what else is left for us to do. So from this vertical axis, I'm going to come over 40 millimeters, down 7 millimeters, and then I'm going to connect the bottom of the 7 millimeter line to the left side of the 7 millimeter line that we mirrored. Okay, so using the line tool, I'm going to come over 40 millimeters, move my dimension out of the way. I'm going to come down 7 millimeters, and then I'm going to connect my two 7 millimeter lines just like this to create a profile. We see that it turned blue, so we know that there isn't any gaps and everything is connected for us to then revolve the shape. Our next step is to add our chamfers and our fillets to our profile so that we can, start to pick out our edge type and kind of start to refine our shape a little bit more. Okay. So the first step we're going to do is we're going to add a chamfer with equal distance. We're going to select our corners here. So select this line, this one, and we're going to set 3 millimeters. Okay, and then we're going to go ahead and do the same operation on the opposite side. Chamfer, equal distance chamfer, and then select this corner over here at the top right hand side of our profile, and then we're going to set this to 3 millimeters as well. Okay, and hit enter. So we have 3 millimeter chamfer, and with this chamfer you're just seeing that it's cutting down to 3 millimeters and then it's cutting forward 3 millimeters, and it's giving us this 45-degree angle into our profile. Okay, I'm going to center our sketch, and our next operation is to create a fillet. And the fillet's going to go here, and this will be a 2mm fillet. Okay, and the reason you add fillets and chamfers into your design, it just helps to improve things for manufacturing. And if we look back at my original sketch here, you see that I also created a chamfer around the bearing. So let's go ahead and do that as well. And you see that this line is overlapping the bearing. So by adding a chamfer down there, hopefully it clears that up. But I'm kind of doing this intentionally so that I can show you that once you adjust certain tolerances, oh, wrong edge. I want it to be this top edge here. So chamfer equal distance, and I want it to be this top corner between the 5.75mm line and the 7mm line. So I want to select that one, and then I also want to select the one over on the right hand side as well. And this will be 0.75mm, and then we can hit enter. Okay. So, oh, something happened that we need to adjust. So this is 0.75, and to change your dimensions, you just select on the dimension tool that you have here, and then you can update your geometry. But as we can see here, our profile line is still over the bearing that we've drawn, so when we revolve this, it might connect these bearings and make them one solid object, which we don't want to do. So we're going to adjust this 5.75mm dimension and just change it to 5 and see where that puts us. Okay, and now we have a nice tolerance built around our entire shape with this little gap, which is just going to allow things to expand and contract in the real world if this part was to become manufactured. So our profile is now complete. Let's hit finish sketch, and we can now revolve the sketch that we created. So using our revolve tool, we'll revolve. It's already selected the profile I want to use, and now I just need to select the axis, which was the horizontal axis in the sketch that I made. So the sketch has gone 360 degrees, and if you adjust this, this can change the angle of what your object or how many revolutions or how far this object is going to travel around this axis. And so since we're making a wheel, we want it to go the full 360 degrees. The operation is to create a new body, so none of this stuff is connected. Even if there was overlapping parts, it wouldn't be connected or creating one body from if it was to be overlapping other objects. So I'm going to hit OK, and now our wheel is complete. So let me center this, and then we can rotate around to see what we did. So this is it for our how to design or 3D model a skateboard wheel, and I will see you in the next tutorial. Thank you.